Welcome friends, this is Atanu Chaudhary of SureSolve. Today in the second part, we'll take up the SSC CGL Tier 2 solution set 17 on Algebra 6 from SureSolve.com and solve the last 5 questions. Let's solve the first of this difficult set of 5 problems. Question 6 is, if 3x plus 5y plus 7z equal to 49 and 9x plus 8y plus 21z equal to 126, then what is the value of y? Option A is 3, option B 5, option C 2 and option D 4. We all know that to solve a set of linear equations in n number of variables, the stringent condition is the number of distinct equations must also be n. Here, this inviolable condition is apparently violated. The two equations are in 3 variables, one equation short, and still we are asked to find the value of one variable y. This is the focal point of interest of the problem. We reason solution is only possible if we are able to reduce the number of variables to 2, y and the dummy variable p in x and z. Can we form such a relation between x and z that is same in both the equations? This is the requirement specification for the solution. We won't then be able to determine the values of x or z, but we would easily find the value of y. So we look for such a possibility. A problem-solving truth is, when you know what to look for, chances of finding it increases greatly. This time also, in a few seconds we identify the desired x and z relation that is repeated in both the equations just as we expected. 3x plus 7z in the first equation and 9x plus 21z in the second equation. This is 3 times of the first. Promptly we substitute a dummy variable p equal to 3x plus 7z. And transform the two given equations to 5y plus p equal to 49 and 8y plus 3p equal to 126. Two equations in 2 variables. Mentally multiplying the first equation by 3, you get 15y plus 3p equal to 147. Now subtract the second transformed equation from this, resulting 7y equal to 21 or y equal to 3. Answer is option A, 3. With focused analysis, the problem could be quickly solved all in mind. Let's solve the next problem. Question 7 is, x, y and z are real numbers. If x cube plus y cube plus z cube equal to 13, x plus y plus z equal to 1 and x, y, z equal to 1, then the value of xy plus yz plus zx is option A 1, option B minus 1, option C 3 and option D minus 3. You have to know that you will get the term xyz only in the expanded form of x cube plus y cube plus z cube, and that is x cube plus y cube plus z cube equal to x plus y plus z multiplied by x square plus y square plus z square minus xy minus yz minus zx plus 3xyz, or 13 minus 3 equal to 10 equal to x square plus y square plus z square minus in the brackets xy plus yz plus zx. You still have to evaluate x square plus y square plus z square. But that is easy. Square up x plus y plus z to get x plus y plus z whole square equal to x square plus y square plus z square plus 2 times xy plus yz plus zx. Or 1 equal to x square plus y square plus z square plus 2 times xy plus yz plus zx. Subtract the first result to eliminate x square plus y square plus z square. The result is minus 9 equal to 3 times xy plus yz plus zx. Or xy plus yz plus zx equal to minus 3. Answer is option D, minus 3. If you know the relations, solving the problem takes little time as calculations are very simple. Let's solve the next problem. Question 8 is, three numbers are in arithmetic progression. The sum of the three numbers is 30 and the product is 910. The greatest of the three numbers is option A 17, option B 10, option C 13 and option D 15. When three integers are in arithmetic progression, the average of the numbers will be equal to the middle number. Assuming this middle number as A, we can express the three numbers as A minus X, A and A plus X, where common difference between two adjacent numbers is X. Adding the three numbers you get 3A equal to 30 or A equal to 10. And multiplying the three together you get 10 times 100 minus X square equal to 910 or 100 minus X square equal to 91 or X equal to 3. The largest number is then A plus X equal to 13. Answer is option C, 13. Let's solve the next problem. Question 9 is, the value of X which satisfies the equation X plus S square plus 2C square divided by B plus C plus X plus B square plus 2A square divided by C plus A plus X plus C square plus 2B square divided by A plus B equal to 0 is option A, A square plus B square plus C square, option B, A square plus 2B square plus C square, option C, minus A square plus B square plus 2C square, and option D, minus in the brackets A square plus B square plus C square. It's clear that denominators cannot be equalized. So, we would try to form a numerator in X that is same for all the three terms. That is numerator equalization. Equating this common factor to 0, we would get then the value of X. But how to equalize the numerator to a common expression in X? That is the main question. With this clear goal now, it is quickly discovered that if we add B square minus C square to the first numerator, it would become X plus A square plus B square plus C square. That is, X plus A square plus 2C square plus B square minus C square equal to X plus A square plus B square plus C square. And we would get this result if B minus C is added to the first term. That is, X plus A square plus 2C square divided by B plus C plus B minus C equal to X plus A square plus B square plus C square divided by B plus C. So we would go on forming the same numerator X plus A square plus B square plus C square for the second and the third terms by adding C minus A and A minus B respectively. The sum of these three extra additions, B minus C, C minus A and A minus B being 0, the value 0 in the RHS is not changed. The final result would then be X plus A square plus B square plus C square multiplied by 1 by B plus C plus 1 by C plus A plus 1 by A plus B equal to 0. Or X equal to minus in the brackets A square plus B square plus C square. Answer is option D, minus in the brackets A square plus B square plus C square. Let's solve the last problem. Question 10 is, if AX plus BY plus CZ equal to 20, A square plus B square plus C square equal to 16, and X square plus Y square plus Z square equal to 25, then the value of A plus B plus C divided by X plus Y plus Z is option A 4 by 5, option B 3 by 5, option C 5 by 4 and option D 5 by 3. It took a few moments to discover the key pattern that the value of the product of the RHSs of the second and third given equations, that is 16 multiplied by 25 is 400, and that is equal to the square of the RHS of the first given equation, which is 20 square. So by variable ratio equality concept, it follows that the ratios of the two sets of three variables are equal. That is, A by X equal to B by Y equal to C by Z equal to, say, P. It follows A equal to XP, B equal to YP and C equal to ZP. Adding the three equations, A plus B plus C equal to P multiplied by X plus Y plus Z. Or A plus B plus C divided by X plus Y plus Z equal to P. Substituting values of A, B and C into the first equation now, A square plus B square plus C square equal to 16, or P square multiplied by X square plus Y square plus Z square equal to 16, or P equal to 4 by 5 equal to A plus B plus C divided by X plus Y plus Z. Answer is option A, 4 by 5. Let's state the variable ratio equality concept we have used. If A by X equal to B by Y equal to C by Z, then A square plus B square plus C square multiplied by X square plus Y square plus Z square equal to AX plus BY plus CZ whole square and vice versa. For detailed solutions to the problems and proof of this advanced algebraic relation, read the corresponding articles in our website suresolve.com. Links are given in the description of this video. And please do subscribe to our channel for latest uploads. Thanks for watching.